Scientific notation. After you watch this video, you should be able to explain what scientific notation is used for. So what do we use it for? It's pretty simple. Really large or really small numbers take a lot of time to write. So if we actually come up with a new way of writing really big numbers that kind of saves us time, it makes sense. The same thing with like a really small number, like 0.00000000000000001. That took a long time. Well, scientific notation is a faster way to write small numbers like that, or really large numbers like this. So there you go. That's why we're going to use scientific notation. I've not shown you what it looks like yet, but that's what it's designed for, to write these really big numbers or small numbers quickly and accurately. Imagine how easy it would be to leave out a zero accidentally. So you can imagine about the number of problems that you'd have working with a lot of numbers that are really big or really small, and then try adding them or subtracting them or multiplying them or dividing them. And that's where scientific notation comes in. So again, why do we use scientific notation? To let us quickly and accurately write these really large and really small numbers. Now, here's what the format looks like for scientific notation. You have what I call a front number. And this front number, it's got to be bigger than 1 but less than 10. Now that's the actual rule right there. It's got to be bigger than 1 or at least 1, but it can't be 10. So it's somewhere in between there. If you're wanting to look at a common sense method of how to boil that down, it basically means this. The decimal is always after your first number that's not 0. So see this 1? That's not 0. Put the decimal point right there. That's the way it's got to be for proper scientific notation. Now, this right here is a multiplication sign. I use the X because it's just the easiest thing I could use to show multiplication. And then it's always going to be a base of 10, and it's going to be raised to a certain power. So it's 10 to the 8th power in this case. This is what scientific notation looks like. What does it represent? It literally means 1.304 times 10 to the 8th. And if you put this in your calculator, you'll get 130,400,000. So that's what we're trying to do. This is actually a pretty small number. I would not recommend using this for scientific notation, but for our examples, we'll do it because it's easier to check with a calculator and to see if it's right. Keep in mind that this right here, the scientific notation, is the same as if we took the 1.304, that front number, and times it by 10 to the 8th. That would be actually 100 million. So you take 1.304 and times it by 100 million, and you get the same answer. This 10 to the 8th is the exact same thing as 100 million. So keep in mind, this is not something brand new. We're just basically taking this idea of a multiplication problem and helping it write these really large numbers, because now we can do something like 2.6 times 10 to the 50th power. Now that is going to be a really big number. And in fact, you'd have to put 49 zeros after this 2 and a 6 to even write this whole number. And that's the main idea of scientific notation, taking these extremely large numbers that you can't write in this traditional method, you know, like this right here. That would just take you way too long to write it quickly and accurately. So again, that's why we're using this scientific notation. Again, let's review real quick. For the proper scientific notation, that decimal always needs to be after the first number that's not 0 on this front number. And then it's always going to be times 10 to a certain power. And that's all I'm concerned with teaching you about right now. So how about you hit pause, go through and tell me if this is yes or no with proper scientific notation formatting. Hit play when you're ready and I'll tell you how you did. Number 1 is absolutely correct, yes. 2 is no. 3 is no. 4 is no. And 5 is yes. Let's take a look at about the nose. Here's the main issue. It's that decimal. The decimal should have been moved over to make it 6.1 times 10 to the 27th. Why? It's the first number that's not 0 that needs to have the decimal after it. So that 6 is the first one that's not 0. Slide it over there. And later I'll show you that technically that should be to the 26th power, but I don't care about that. We're mainly looking at this. Decimal placement and times 10 to a certain power. 3, decimal placement again. See, it's got to be after the first number is not 0, so it should be 2.67 times 10 to the 10th. And that's really sloppy. I apologize. Let me fix that. Times 10 to the 10th power. Same issue here. Here's your invisible decimal. In this case, it should have been moved over 2 times. So that should be 1 times 10 to the 13th. And again, if you're a little bit familiar with scientific notation, you know I should have changed the exponents here. I've not taught you that yet. That'll be for future lessons. My main thing is this. Make sure your decimal is always after the first number. It's not 0 times 10 to whatever power that it is.